All right, AP Chemistry. This is the answers video for the Thanksgiving review assignment. The assignment deals, is very similar in many of the problems taken from day 18, day 19. It has to do with solution stoichiometry. And I chose that because we kind of rushed through that back in the day that we did it, in the time that we did it. And it's very important when it comes to acid-base chemistry, as well as equilibrium. Equilibrium and solution stoichiometry are really central to acid-base chemistry, which is what we're going to be doing in the next 3 weeks. So we'll go ahead and work through a number of problems to hopefully shore up your ability to do these problems. So I've included the measures of concentration sheet so you can use that as you need it to do these problems. Okay, let's get started. Okay, so this assignment is in an A-B format. The A problem and B problem are identical except for the numbers. So I'm going to do the A problems with you. You do the A problems as well, and then you do the B problems on your own. I'll provide a sheet later on that will give you the answers to the B problems, just the final answer, not all the steps. You do those on your own, but you at least will know whether you did it correctly. Okay, so what is the molarity? 4.7 moles KOH in 350 milliliters of solution. So to get full credit, I'm going to be pretty strict about this. I want you to write out the formulas for each of these things, so that the general formulas for these. So molarity. Okay, so the general formula for molarity is moles of solute over liters of solution. Remember, solute is, think of your lemonade example. Solute is the lemonade powder. Solvent is the water. And solution is the lemonade powder mixed in the water, the two of them together. So that's what we're talking about. And we abbreviate solution SOLN. Okay, so that's the general formula. That's what I want you to see. That's how you end up memorizing formulas without trying, is write them out every time. Okay, it doesn't take that much extra time. Okay, so we're going to go ahead and it's asking for, we're going to set up our stoichiometry. And whenever you see molarity, you don't want to write it as big M in an equation. You want to write it as what it is. So what we're looking for is moles of KOH, potassium hydroxide, for every liter. And you can put the number 1 just to emphasize that you want 1 liter on the bottom of solution. So that's the potassium hydroxide and water mixed together. All right. So what you start off with over here is moles and some number of milliliters. Remember, the way you do stoichiometry, and you just got to get used to this, is you just try to play with the units to get them to match up what you're looking for in the end. We're looking for moles of KOH over liters of solution in the end. Okay, here we have 350 milliliters of solution. Okay, and we need some conversion, 1, 2, whatever it takes. Well, we see we already have moles of KOH on the top, so that's done. The top is taken care of. The way we did these problems, and the way you always do these problems, you treat them as 2 different problems. First, you deal with the top, and then you finish that, and then you deal with the bottom. You can do the bottom first if you'd like. That doesn't matter, the order. But you want to do I usually start with the top, get it to match up, and then bottom. So top already matches up. It's moles of KOH, moles of KOH. On the bottom is milliliters of solution to liters of solution. So there's the standard conversion that you should just flat memorize, and it's 1 liter equals 1,000 milliliters. So that gives us, that's called an equivalency, and this is true of any substance. We're interested in solution here, but this is true of any substance. So we can write that as two conversion factors. Okay, so again, the 1 liter for every 1,000 milliliters is true of any liquid or any solution. But we're interested in solution here, so we go ahead and add solution. We always want a unit of measure and what the substance is. Again, instead of solution, you could have written KOH plus H2O, but that's kind of long to do that, and there's no point in doing that. So as long as you understand what the solution is, you don't have to do that. So we need a box here. Okay. And which one of these two are we going to put in that box? Well, we have milliliters on the bottom. We need to get rid of it and get liters on the bottom here. So we're going to use this one right here. So milliliters of solution and milliliters of solution cancel, bottom, top. And we're left with moles, KOH on the top, liters of solution on the bottom. Okay, so now it's just math. We multiply everything on the top. So that's going to be 4.7 times 1,000. And then divide by everything on the bottom. Let me get it so you can see the calculator here. And then divide by everything on the bottom, which in this case is 350. And that gives us our final answer of 13.4. We're not going to worry too much about significant figures, but we might talk about them on the way. So you have two significant figures there, so that would limit it to 13, but I'm going to call it 13.4. Okay, and that's your final answer. So you're going to go ahead and do 1B. It's exactly the same. I just changed the numbers. What you should do is be sure you understand this first. Then go to 1B and see if you can do it. Just completely cover this up here, cover that up, and see if you can do 1B without looking at it. That's really your goal, is to be able to do this problem without looking at an answer. All right. Okay, 2A, let's move on. So it's how many moles, so this is what we're looking for, of HCl. So right away you can come down here. That's where your answer goes, and it's moles. And substance. Okay, and remember, that's always Cl. It's not C1, it's not Ci. It's always Cl. When you see a C followed by what looks like could either be an L, a 1, or an I, it's a Cl. All right. Now, this presents a little bit of a, you got a question a little bit. You've got a unit of volume, milliliters, and molarity, which has two levels to it. You never put molarity in an equation, almost never, okay? You're going to see an exception later on. Never put molarity in as big M. You put it as moles of solute, that would be HCl, over liters of solution. So you already have two levels, a top and a bottom there. So generally, you're always going to start with the molarity, so I'm going to put that way down here. Now, sometimes a mistake a student will make is they'll say, well, I've got a volume here. That should go on the bottom of molarity. No, molarity is always moles per 1 liter. It's just a fixed unit of measure. It's whatever the number is that you have of molarity, but it's always over 1 liter. So that doesn't go on the bottom. So when we compare this to our answer, we have moles of HCl on the top, and we have moles of HCl on the top here. So we're done with the top. The top is done. We don't have to do anything else with it. But we need to get from liters to nothing. There's nothing on the bottom here. So basically this unit has to cancel. So how do you get liters to cancel out so that it doesn't even exist? There's nothing even here on the bottom. Well, that's where this number is going to come in. Okay. So what we're going to do is we are going to say that we're going to need two conversions. The first one is this one. And we've already set up the two conversions in 1A. And then we have this, okay, this number to use. So what we're going to do first is we're going to convert liters to milliliters on the bottom. And then we're going to multiply by this 882 milliliters up on the top. So watch how this works. Seems a little tricky the first time you do this, but it's not too bad. Okay, so now liters of solution is canceled. Now you have 1,000 milliliters of solution on the bottom. Okay, so what we're going to do now is we're going to put 882, I'm being distracted here, 882 milliliters of solution, because that's what it is. There are 882 milliliters of 1.2 molar aqueous solution. So the 882 refers to solution. Okay, so liters cancel with liters, milliliters of solution cancels with milliliters of solution. So you now have no more units on the bottom there. The units on the bottom are gone. So what you're going to do again is multiply everything on the top. And that's going to be 1.2 times 1, which you don't have to put in, times 882 divided by 1 divided by 1,000. Okay, and that gives us 1.05, and we'll just round that up to 1.1. And we're not paying attention to significant figures, but it would be two significant figures based on that. So again, 1.2 times 1 times 882 divided by 1, divided by 1,000. But the units on the bottom canceled out, so there's no units on the bottom anymore. And so that gives us our final answer, okay? All right, and you do 2B. And we'll move on to 3A now. Okay, 3A, what is the molarity of 6.1 grams NaCl dissolved in 0.53? And somehow this got in there, so let's just scratch that out. All right, I mentioned that in class. Get rid of that. So it's 0.53 liters of solution. All right, so you're starting off. Now you want to put this on 2 levels, grams per liter. So we're going to come up here. And it's grams of the solute, NaCl, sodium chloride. That's table salt. Okay? And what are we looking for? We're looking for the molarity. So we're going to come way over here. We don't know how many conversions we're going to need, so put it way over here. And that's moles. Okay. So on the bottom, we have liters of solution, and we end with liters of solution. So the bottom is fine. We don't need to do anything with the bottom. You have the correct units of measure. On the top, we have grams of NaCl. We need to get to moles of NaCl, and this is something you've done a million times, and that is the molar mass. You need to use the molar mass of NaCl to convert those two. Okay, so we get a periodic table. Should always have a periodic table out, and there's Na is 22.99, and chlorine is 35.45, so you simply add those two together. And that gives us 58.44 for the molar mass of sodium chloride. Okay, so we'll write our molar mass equivalency. And again, at this point, you don't have to write this all out every time if you know how to do these quickly in your head. That's what you eventually want to get to. Remember, molar mass is always 1 mole of the substance. Okay, so that gives us 2 conversion factors. Again, you don't have to write these out explicitly anymore like this, but be sure you know how to do it. You put either or an equal sign. I like to put the word or because it emphasizes we're going to choose one of these to put up here. Okay, there are our 2 conversion factors. So we're only going to need 1 conversion. I left all this space because sometimes you don't know how many conversions you're going to need when you first start a problem. But we just need 1. Okay, again, we're done with the bottom. The bottom is already good. What do we do to get top from grams to moles? Which of these 2 do we put in the box? Grams on top here means grams on bottom here. So we're going to pick this one. So grams of NaCl cancels and cancels. We have moles of NaCl on the top. That's what we need. Liters of solution on the bottom. That's what we need. So now it's 6.1 times 1 on the top, and then divided by 0.53 on the bottom, and divided by 58.44 on the bottom. And that gives us 0.19. I'm just going to call it 0.20. You call it, I'm not picky about the significant figures here, but just to now there's 2 significant figures there. So you don't count when you have a conversion factor. The 1 mole is a standard you're comparing. This is the measured value. This is a value you're just saying, I want to know how many grams in exactly 1 mole. So the 1 mole is an infinite number of significant figures. It does not limit your significant figures. What was the measured value is this. You could find some periodic tables that have this mass to 7 significant figures. We don't do that. We have one that does it to 2 places after the decimal. Okay, so don't let the 1 mole in this limit your significant figures. Okay, and that takes care of that. Okay, number 4A. This represents a kind of a common problem that you could actually have in the lab, where the teacher says, maybe you're doing an acid-base reaction, and the teacher says, I want you to create 500 milliliters of a 1.2 molar NaOH solution. You want a very specific concentration and a very specific volume. So you have to go back and figure out how many grams of NaOH would be required to do that. You get the container of NaOH, and you have to measure out how many grams it would take to do that. So this is kind of a real-world type of problem that you might have in a lab. So they're asking how many grams NaOH, so we come over here. Again, for this, you're always looking for the how many of something, or what is the volume, or something that tells you what you're looking for, how many grams in this case. All right, now again, we have a situation where we have molarity. Molarity is moles per liter. That's got two levels to it, a top and a bottom, and then you have this. So it's somewhat similar to the problem that we had a couple problems back. All right, so we're going to start over here with 1.2 molar, but we're not going to write it as molar, big M. We're going to write moles. Okay, so let's look at what we have here. You have on the top moles of NaOH. Over here you have grams of NaOH, so you're going to have to make a conversion there. Then down here you have liters of solution, and over here you have nothing. So this liters of solution is going to have to disappear. So now we have to deal with the top and the bottom. So we're going to go ahead and deal with the top first. So it's moles to grams. That's a grams to moles conversion. Okay, we go to the periodic table. We got Na is 22.99. H is 1.01. That gets us up to 24. And then 16 for oxygen is 16. So NaOH comes out to be exactly 40 grams per mole for its molar mass. Okay, this time I'm not going to write both of the conversion factors. We know that this one over this one, or this one over this one. It is always the way it's going to be. Now we have liters of solution. So let's go ahead first and deal with the top. So what we have is we have the first box has got to make moles turn into grams. Okay, so one of these is on top, one of these on bottom. Which is it going to be? You have moles here. It has to disappear because you want to end up with grams on the top. So it's got to be moles on the bottom. Okay, so moles on top cancels with moles on bottom. So now you have grams of NaOH on the top. That's what you want. All right, now we got to do the same thing we did a couple of problems back. We got to convert liters to milliliters. We're going to use this to make everything on the bottom cancel out. So first we have to convert this. If you want to draw a box, you can. And it's of solution. So liters of solution here cancels with liters of solution up over there. So now we have milliliters of solution on the bottom. We need to get rid of that. I'm going to give myself a little more space here. That's why I really should have started writing this way over here. You just don't know sometimes how many conversions you're going to need. I knew, but I didn't give myself enough space. Okay, so now we put the 500 milliliters on top. And that's of solution. Okay, so milliliters of solution cancels with milliliters of solution. We have nothing, no units left on the bottom. And we have our grams of NaOH on the top. So now it's time to go to the calculator. 1.2 on the top times 40 on the top times 1 times 500 divided by 1 divided by 1 divided by 1,000. Of course, you don't have to divide the ones. Okay, and that gives us 24, exactly 24 grams. And I'll just leave it at that. We can go to 4 significant figures there if we want. I take that back. We can only go to 2 right there. So it'd be 24 would be it. So how would you write that? You just leave off the decimal place. Okay, and that means just leave off the decimal place there. Okay, don't put any zeros behind it. So that's your answer, 24 grams. Okay, so again, a lot of this is just playing with the units and figuring out how can I get the units to cancel properly, and you just get better at that with practice. But you will get there if you're willing to practice this. Okay, let's go on to 5A. All right, you want to create 1,259 milliliters of a 1.2 molar NH3 solution. How many grams of NH3? Very similar to the last problem. In fact, identical to the last problem. But again, this is the kind of problem you might come up with, have in an actual lab situation. You got to go figure out how many grams of NH3 ammonia to get out of the container in order to make this volume of the solution at this concentration. All right, so we want to know grams of NH3. So I'm going to move through this one a little quicker. Okay, and again, you have milliliters, you have molarity. We're always going to start with molarity way over here, and I'm going to put it way over here this time. Okay, so we have liters of solution. Hope you caught that before I did. Just the definition of molarity. So we have liters of solution on the bottom here, nothing over here, so that has to disappear somewhere in the problem. We have moles and grams, exact same thing as last time. So we're going to go to our periodic table. Okay, so nitrogen has a molar mass of 14.01. You have 3 hydrogens, each 1.01, so that's going to give you 17.04 for your molar mass for ammonia. Okay, again, the box is optional. You don't have to draw the box. Just trying to make it as visual as possible. So one of these top, one of these bottom, which is it? Well, this has to cancel out, and we have to end up with grams on the top, so this goes on the bottom. Usually the best way is to ask the question, which one goes on the bottom? It's always this one. Now, you'll see in some of these problems, for example, liters, we're going to skip over a couple places before we get to liters. So you kind of have to just watch that. All right? Okay, so moles of NH3, moles of NH3. We now have grams of NH3 on the top. That's what we want. So we're done with the top. Now we need to take care of the bottom, and we do it exactly the same way as we've been doing it. Okay, so now we have milliliters solution on the bottom. We need it to go away, so we're going to put this up on the top. I just drew the box this time just to emphasize. You don't have to have anything on the bottom. You don't have to, and we don't want it in this case. So we have no units on the bottom anymore, and we have grams NH3 on the top, so now we multiply. And I see I made an error. It should be 1.12. I'm sure you caught that about 5 minutes ago. Okay, so 1.12. And I always check my work afterwards. I try to. Let's be sure the other numbers are correct. 1.259. Okay, so 1.12 times 17.04 times 1 times 1259 divided by 1 divided by 1 divided by 1,000. And that gives us 24. Wow, we're getting the same numbers. 24, this one's 24.02. Just gonna, we can go to 3 significant figures because of that. So I'm going to call it 24.0. Again, the significant figures, just look at the numbers, not counting these types of conversions. This is a pure conversion. It's not a measured value, in other words. It's an exact value. This is saying 1.12 for every 1 liter. That's not a measured value. That is. Okay, so you just learn to kind of sense what's, when do you limit. Generally, if it's just a single number like that, it's not going to limit your significant figures. All right, so that's what we got. All right, and you go on and do 5B. And I am going to go ahead and post the answers for 1B through 5B. Just the answer, just the final answer. I'm not going to work the problem. So that's for you to do. You need to show your work. Do it neatly. Remember, presentation, they don't grade you on presentation on the AP exam. However, you want to make it easy for the grader to give you points, and you want to make it easy for them to follow your work. So presentation is important. Okay, I'm going to break this into a series of different videos. So this is the first one, and you will have the other one coming up very shortly.